Hey everyone, this is Tom Salemi of DeviceTalks. Welcome back to the Neuro Innovation Talks podcast. I'm here with our host, John Murray. John is head of global strategic marketing of J&J MedTech Neurovascular. John, another great episode coming up.
Excited to do it, and this has been some journey, Tom. Thanks again for the partnership. I'm really pleased to be able to be part of this series.
Oh, it's fantastic to have these look or listen inside the hearts and minds of the KOLs in this space. So today you sat down with Dr. Jacques Moret. He is the professor of interventional neuroradiology and honorary chairman of the NEURI Center and Bicetre University Hospital in Paris. What were some of your takeaways with Dr. Moret?
Yeah, what a fantastic interview with Dr. Moret. As you know, Tom, we were very thoughtful about which physicians we wanted to feature in this podcast, and those were people who very early on in their career helped to define this field, and those that expanded the boundaries of what was possible in neurovascular, and who created these trailblazing innovations. And Dr. Jacques Moret is no exception. He certainly embodies these pioneering traits. And I can tell you, I think we covered almost all of them in our discussion. We spent some time talking about the evolution of balloon remodeling, and we dug into the history of how he conceived this idea. And I think the listeners, no matter who they are, will be interested to hear about the personal and professional journey that led him to this groundbreaking innovation. I also think that something people may not always realize with these visionaries is that while they are so well known as individuals, they're also truly committed to advancing their entire discipline. This is the neurovascular field, and that could not be more true of Jacques Moret. So I'm excited for our listeners to hear just how selfless and generous a physician, mentor, and leader he is. So let's begin our conversation with Dr. Jacques Moret.
All right, well, before we begin this episode, I want to bring in our sponsor, Confluent Medical. I'm here with Tom Ditter. He's Senior Director of Product Development at Confluent Medical. Tom, Confluent's made quite a bit of noise in the medical device space this year, specifically surrounding nitinol, which has been just really an exciting topic of the year and of the past couple of years. Before the company was Confluent, it was known as NDC, which stands for Nitinol Devices and Components. Can you give us a quick overview of how Confluent got to where it is today and how your history is connected to NDC and to nitinol?
Yes, before it was called Nitinol Devices and Components, it was actually known as Nitinol Development Corporation. And the philosophy of the founders was to understand the fundamental material science behind nitinol and to use that to design and process components made from nitinol. Now, Confluent continues its legacy today throughout its capabilities. It focuses on the material science of not just nitinol, but also polymers and textiles as well.
That's really interesting. And as a contract manufacturer, your job is to assist OEMs in taking a design from prototype to production. Can you give us some examples of how Confluent's accomplished this recently? Few cases you've worked on. I know you have to probably be sparse on details, but what are some of the things you've been working on?
Confluent is fully integrated and has the capability to take a product from prototyping to development, optimization, and full-scale manufacturing. We recently just worked with the OEM on a novel neurovascular stent. We assisted them in initial design iterations, process development, to full-blown manufacturing.
Tom, Confluent Medical is a contract manufacturer, which means you assist OEMs in taking a design from prototype to production. Can you give us an example of how Confluent has recently accomplished this?
Yeah, yes, as you mentioned, Confluent is fully integrated. We do have the capability to take a product from initial prototyping to full-scale manufacturing. We recently accomplished this with a OEM that was working on a novel neurovascular stent. We worked with them on the initial design iterations, took it to process, development, optimization, and finally to full-scale manufacturing.
Well, welcome to the podcast, Professor Moret. Thank you so much for joining me today. It's an absolute honor to have someone of your stature join our podcast series. Before I start, I just wanted to share with you just a little history of how I met you and how we first interacted. I was traveling in the field. Oh, it was about 20 years ago in Paris. And you welcomed me into your lab to observe an aneurysm coiling. So I want to thank you for the opportunity to train and educate me. And subsequent to that, you traveled to Miami to participate in a training for our sales force. And you talked about the importance of small aneurysms and treating them with coils. And of course, as we'll get to in the podcast, balloon remodeling and some of the inventive work that you did. But I want to thank you personally because it's been part of my learning and my journey to spend time with experts like yourself and educating people in industry on the importance of understanding the disease state. So it's much appreciated.
It was a pleasure at that time, and it's still a pleasure today.
Professor Moret, clearly you're considered a pioneer in the neurovascular field today, but when you first started doing procedures in the brain, the field literally did not exist. And what was it that drove you to commit your energy and resources to addressing these unmet needs? And was there ever like an aha moment along the way where you felt, wow, this is amazing?
I love this word, the aha moment. There was some kind of aha moment, definitely, but my interest came basically from some rumor coming from a guy working in Bicetre University Hospital whose name was unfortunately René Gingian. And for the very first time, René Gingian was speaking about treating spinal cord vascular malformation by screwing a little bit of pieces of dura mater. He was cutting in small pieces the dura mater of the pig to inject in the vessels supplying the malformation to reduce the flow of the malformation. Of course, he didn't invent the idea. The idea was invented already quite a long time ago, not especially for the CC fistula, with pieces of muscle that were injected in the carotid artery to get inside the venous part of the CC fistula. But this was the very first time I heard that maybe it's the way to go. I was very young at that time, and I say doing surgery without opening the skin and being less traumatizing is probably the future. And I decided to move in that field, the field which was not existing. So I had some relationship with René Gingian. To give some memory to René Gingian, he was a neurologist working in Lariboisière. He was so recognized by the professorship position and leaders in the field of neurology because he was too much eccentric. He was too much outside of the box. And at that time, being outside of the box, it's not really very attractive. But definitely, I had this impression that probably this was the way to go. And at that time, I was doing my internship in a Neuroradiology department, which was headed by a phenomenal lady whose name is Jacqueline Vigneault. And when I spoke to Jacqueline Vigneault, she told me, Jacques, if you want to do this, I will support you. I am not pros. I am rather against what you want to do. But if this is what you want to do, I will help you as much as I can. Of course, if you stay in the department and if you keep on working. So I said, why not? And then I started doing this. The interesting thing is I had such a tremendous support, and I definitely, recognize that without her, probably I would have chosen what I was supposed to do originally, which was pediatric surgery.
Great history there, and you had some vision for sure. When people, you did. It was obvious.
No, yeah, definitely. I had the vision. I can say that I had the vision.
I think when many people hear your name, they certainly think about the art of balloon remodeling and its treatment of brain aneurysms. I want to talk about this for just a moment. Can you share how you conceived this technique, kind of how it came about? Even if you can, walk us through some of the steps as to how it evolved. Because for some people that are learning, using a balloon in the brain to treat an aneurysm is fascinating, and would love to learn more about that.
The idea about the balloon remodeling came after my first attempt of treating aneurysm with detachable balloon. The detachable balloon came on the market around 1972 or something like that, 2 or 3. And basically it was Professor Serbilenko from Burdenko Institute in Moscow. He definitely invented the detachable balloon. So CC fistula at that time, traumatic CC fistula at that time was pretty frequent. And it was a good idea to develop and continue to use this technology for CC fistula. But of course, my impression was, why don't we do it for aneurysm and place a balloon in the sac of the aneurysm and let's see what's going to happen. At that time, there were basically 3 doctors all around the world thinking about doing this. Dr. Shiglov, again in Moscow, Higashida, Dr. Higashida in San Francisco, and myself. So Dr. Shiglov, he came on the market suddenly by publishing about 1,000 aneurysm treated with balloon. Balloon delivered in the sac of the aneurysm, inflated with dye, and then he was claiming that the results were wonderful. So we had no real detachable balloons that small to do the job. And I had the chance to be, I was at that time in contact with an exceptional guy who is the founder of the BALT company, and his name is Leopold Plowiecki. And Leopold Plowiecki was just coming from Poland, and he was doing this catheter extrusion in France, starting having a factory in France. And he was looking for somebody to help him to develop catheters. So he heard a little bit about me, and he came and we started working together. And I told him, is there a way to get a balloon? And he said, okay, but what kind of balloon? So I spoke with him. We had the information that Shiglov was using a latex balloon, on the contrary to Dr. Higashida, who was using a silicone balloon. So we decided to think about developing those balloons. So we produced some tiny little balloons, and we developed a very specific. He developed a very specific detachable system on which I've been working with him. And then we came on the market with a tiny little balloon that was detachable. And the most exciting thing is the micro catheter that he was producing at that time, which is always in production today, which is a magic catheter, which was just floating in the vessel and navigating like crazy. So we started attaching with the detachable system balloon on the flow directed catheter. And by inflating a little bit the balloon, the flow was bringing everything in the vascular tree, but not necessarily, of course, in the sac of the aneurysm. So that's the reason why, I started developing the same balloon, but they were glued by myself, a drop of histoacryl. It was homemade, in the lab. And I was gluing the balloon on the tip of the magic catheter. And it was easy to navigate in the vessel and then to modify the flow because we had no wires, we had nothing. So to use the flow as a kind of rail guiding the balloon toward the aneurysm, I was blocking the flow with 2 or 3 balloons sometimes. And then finally, the balloon, the detachable balloon came in the sac of the aneurysm. The problem is when you look at the result we had compared to the result of Shiglov, we had bad results because the balloon inflated with iodine is deflating pretty soon. After 1 week, it was already half of the volume. So we thought about a material that could be, could be delivered in the balloon and without any evaporation or reduction of the volume or whatever. And this material was HEMA. And HEMA had a very specific way of reacting. The precipitation of the material was depending on the temperature. So I was using, my father was a baker and a pastry, and he was making this model in chocolate, for Easter and everything. And, the chocolate is behaving completely differently if you have 1 degree of variation. So I was using a specific tool to, take the chocolate at the precise temperature, which was, for me, the temperature of the body of the patient. And I had a control on one side to understand how much time the material was taking to get hard. And after that, I could detach the balloon. In addition to that, it was a material that we had to exchange. And I invented this double lumen catheter with an exchange chamber. And Leopold Plowiecki manufactured very nicely this balloon with 2 channels and a chamber. So the dead space of the catheter was just limited at the tip of the microcatheter, which was less than 0.01 milliliter. So it was negligible. So we started inflating the balloon with the HEMA. I was checking that. And then we started having a pretty good result. But this technology was too difficult. It was extremely difficult to spread the technique. The link between the technique and the doctor was too strong and too difficult to achieve. So for sure, this technique had no real future. It was good when you are concentrated on it, but it was too difficult and definitely potentially too dangerous. So this was the first time I was confronted with the circle of Willis selective treatment of aneurysm. It was in 1980. I did my first circle of Willis aneurysm selectively in 1981. So I had a lot of experience with the balloon. And before the GDC coils, we had 3 coils that we were injecting through the catheter. And of course, injecting 3 coils in the sac of an aneurysm, the risk of refluxing, escaping was too strong, too high, too risky. It could not work. And I said, why don't I put a balloon in front of the neck? And that's it. And so this is, why the balloon remodeling came. And then the balloon catheter dramatically evolved. We came with balloon catheter over the wire, so we could keep the balloon inflated. It was extremely easy to navigate, rather easy, not that easy compared to what we do today, but it was definitely a good way to do it. And I developed the balloon remodeling, which is definitely a wonderful technique. I am very proud of this technique. I think it's a very useful technique. A lot of people know the way to do it, but the younger generation are switching directly to, endovascular device. Some coils too, because the coils business is decreasing for sure. But nevertheless, it's still useful.
Wow.
And honestly, it was a nice experience. So it came from balloon treatment, selective balloon treatment of the aneurysm, and 3 coils that we were injecting, the concept to protect the neck, and then we switched to the GDC, which was a revolution. Not necessarily the tool itself, but Guido Guglielmi, who recognized, who celebrates this tremendous revolution he brought on the market. Without him, it would have probably happened, but maybe 20 or 30 years later. So I want to thank Guido today. It's remarkable what he did. It's wonderful what he did.
And I'm hopeful, Professor Moret, that those listening to the podcast here get some perspective on how we got here. And Dr. Guglielmi certainly had a critical role in that for sure. Thank you for highlighting that.
Extremely critical. Thank you, Guido.
So, boy, there's a lot to unpack there. And I'm fascinated because one of the things that I've learned throughout my career is the art of coiling and balloon remodeling. And you connect that to the art skill that your father had as a baker. And really interesting story about chocolate and temperature. So everything coming together created this magnificent technique. However, you did mention along the way, as we know in many procedures, that the early outcomes, they were not perfect. Clearly, they were improving, and we were helping patients that couldn't be helped before. And when you first started testing, whether it was detachable balloons or the balloon remodeling, I'm sure that those complications were difficult for you to manage. What kept you going? What drove you and motivated you to keep innovating and expanding the utilization of that technique?
When you start from scratch, you don't have any references, and it also depends on the period of the time where it happens. 40 years ago, the constraints were less compared to today. And we could definitely do things that it would be not possible to do it today. So it would not be possible to do it today because of regulation, a lot of constraints, which is good. It's good and bad. Why? First, because when we started doing those circular fluid aneurysm, we were doing it in patients that were not really good candidates for surgery. And at that time, when a neurosurgeon was not confident to clip an aneurysm, and the life of the patient was definitely in danger, it was more or less do it, and why not? Otherwise, the patient probably is going to die. So you have this kind of umbrella. So you do something which finally the result is you will help the patient. You can harm it, but definitely the natural history of the disease will harm it too. So the patient would be harmed by the disease, and why not try to do something in a desperate case? So this was the very beginning. And of course, you have to feel ethical with that. And it helps you to support, the complication. After, it becomes more difficult because when the technology is evolving, everything is getting better and better. The neurosurgical, open skull neurosurgical field was clearly understanding that something is moving, and the story of the treatment of aneurysm will never be the same. There was a big change, and everybody was thinking that this was time where we have to think that it's a true way and a very specific way to treat aneurysm. So now it's more difficult, but at the same time, the technology is evolving and the treatment is becoming much easier because of the technology. So we are not confronted with the same risk. Nevertheless, even if today you have an average of 3% total risk of treating an aneurysm, when you have a complication for the patient, it's 100%. So it's difficult. You never get used to the complication. You feel, I would say, ethically speaking, protected when you spend time with the patient, explaining everything, including the complication, giving the numbers, not only the numbers of the publication, but also your own complication rate. You take the risk at the moment of you do the treatment. So honestly, you feel comfortable if you explain everything, if you don't hide anything to the patient. Give the patient the clear understanding of science and your experience at the time you speak. Because, you know, what you say in 2000 is not the same as what you say in 2010, because everything is evolving. So I was feeling comfortable, but nevertheless, each time you have a complication, you don't feel good. You never remember your good case. You always remember your complication.
Yeah.
And, you know, I remember specifically a young patient. It was not an aneurysm. He had a brain EVM. He was devastating. He was having epilepsy, out of control, progressive deficit. He was 18 years old. So despite the fact that he didn't bleed, I told the family, let's try. I don't know. We might improve. I don't know. We started. I did some, you know, stage embolization, and it was, you know, astonishingly improving really. And at the 5 or the 6th procedure I did, he bled and he died. And you cannot imagine the letter I got from the family. You made the life of our son so happy for the last 8 or 9 months. At the time you started doing the treatment, and at the time he died on the table. So, you know, I was devastating, but when you have a family reacting this way, understanding our trouble, understanding our difficulties, honestly, it makes you feeling better. It's a wavy life, excitation, tremendous success, dramatic failure and complication. You have to get used if you feel honest and ethical.
This leads me to my next question that I've been thinking about, which is the fear and pressure and stress in these really difficult cases. And what you just shared about that patient, I know that was devastating and high risk. And in those situations, which I'm sure you've been in many, a split second decision can determine life or death. I mean, how do you approach those really difficult situations and manage that fear, pressure, and emotion?
To be honest, the less you know, the less fear you have. I have more fear today compared to what I had 30 years ago. Because now, you know, I do know not everything, but I do know a lot about the possibility of getting a problem because of a given situation, because of the modification of the situation according to time, or during the procedure, sometimes things are changing brutally. So honestly, knowing a little bit is a good way to push forward. Then it's your own decision and your own ethical way, the way you feel. You know, don't take risk just for being the best. You know, I remember this wonderful words from Alex Bernstein. He's always saying, in an heroic procedure, the hero is the patient and not the doctor. And, you know, each time I want to go more or to do more or to push a little bit, I am always thinking about these words from Alex, you know, be careful, the hero is the patient and not the doctor. You know, it's your intimate sensation and perception. So, of course, intimate sensation and perception is completely different depending on a given person. So there is no classification, there is no possibility to say who is good, who is right, who is wrong, but, you know, play with your ethical way of perceiving the problem.
Wow, that's great too. Let's shift gears a little bit and talk about, you know, you obviously we've talked about your innovation, your techniques, but you're also very well known for deep knowledge of the anatomy. And this is part of your background, which I'm sure has informed the way you approach your patients. Can you talk about how that has influenced your technique and maybe anything that you want to share about that learning in your career?
Yes, it's a fundamental point in my career. I had the opportunity to do my fellowship with Pierre Lagenias, and Pierre Lagenias was deeply involved in anatomy. And at that time, we were starting all together, and we did not understand too much all the complications that were reported from external carotid embolization, because we started through the external carotid system, thinking that the external carotid system was less dangerous than the internal or the vertebral system, the cerebral arteries, which is true. But all the complications that were reported, were linked to a lot of dangerous anastomosis or dangerous territory that we didn't know. So Pierre Lagenias, decided to think about that. And as far as we were working together, I was in charge of the selective and geographic aspect, having the best picture of all kind of tiny little vessels that we could get in the base of the skull. And then it was dissecting the head of the patient, and the vessels of the cadaver were injected with a specific solution whose secret was given by Georges Salamon. Georges Salamon was a neuroradiologist in Marseille. He published a wonderful atlas on the microvascularization of the brain. And we have been using his technique, and he gave us the secret of this special material that he was injecting in the vessel. And due to that, we could get the precise correlation between the angiography, the microradiography, and the dissection done by Pierre Lagenias. So after, let's say, 2-3 years, we were to both of us the king of, the base of the skull microanatomy, and it had dramatically helped us to understand better and to teach everybody why we were reporting these complications. So Pierre is the other guy that, has dramatically helped me in my career. So there was a wonderful synchronization between, Pierre and myself. In addition to that, he was working in Bicetre Hospital, where I finished my career now. And the boss of the department, Dominique Doyon, was such a nice person. So, Pierre had a wonderful chief, and he had the same philosophy as Jacqueline Vigneault. If this is what you want to do, do it. Despite the fact that we brought a lot of complications to Jacqueline Vigneault and to Dominique Doyon all together, because having in a department 2 guys like Pierre Lagenias and myself, it was not easy. Honestly, it was not easy. But finally, we were producing so much that they were very happy, and we got such a tremendous support from both of them. Nevertheless, the primary seed and the primary result are definitely depending on Jacqueline Vigneault and Dominique Doyon. But among this hostile environment, neurosurgical environment, we had Pierre Lagenias and myself a tremendous chance, because the neurosurgeons we were working with were completely supportive too. They understood before most of the neurosurgeons that this was the way to go. And Michel Hurt in Bicetre and Honorary in Beaujon, when I got my professorship position, they just said, okay, this is the future of neurosurgery, so we will support you too. So, it's not only our enthusiasm and some of the quality that Pierre and myself have, it's also the environment.
I will take a quick break from this conversation to bring back our sponsor, Confluent Medical. I'm here with Tom Ditter. He is Senior Director of Product Development at Confluent Medical. Tom, nitinol is growing in popularity. We're seeing more and more OEMs are turning to it. This alloy has shape memory. It has super elastic properties. Can you explain how Confluent sets itself apart from other nitinol suppliers?
Well, Confluent has over 30 years of experience in the design and processing of nitinol. But beyond that expertise, Confluent identified a nitinol supply chain gap. They invested over 100 million across the supply chain. Most recently, they just made an investment of over $50 million in additional melt and conversion capacity, becoming the fulfillment partner for one of the largest melt suppliers in the industry.
So, Tom, we're hearing so much about nitinol's super elastic and shape memory properties. It makes it an ideal alloy, specifically within the neurovascular space. Can you speak to how Confluit's expertise is able to meet the growing demands for OEMs in the neurovascular market?
Yes, for neurovascular applications, durability is a major consideration, and Confluent Medical has invested heavily in the development and processing of high purity alloys for increased durability and fatigue resistance. Our material SE508 Eli is one of the highest purity materials available and ideal for high cycle fatigue applications, as found in neurovascular devices. Additionally, Confluent specializes in high precision polymer tubing, such as film cast PTFE. This makes us unique in the neurovascular space in that we can offer PTFE with thinner walls and larger diameters, making it ideal for large diameter aspiration catheters.
So, Tom, that's super interesting about the neurovascular space. So, what does the future look like for nitinol in the neurovascular device market?
The demand for minimally invasive procedures is growing, so we can expect to see nitinol as a key alloy for these devices. Future applications such as neurovascular devices will need to have a smaller profile with an emphasis on durability. Additionally, high purity nitinol is needed to address high fatigue applications to prevent fracture and improve longevity for patients.
Well, this has been really entertaining and insightful, Tom. Thanks for joining us on the podcast.
Thank you, Tom. Glad to be with you.
And thanks to Confluent Medical for sponsoring this episode. If you'd like to find out more about Confluent Medical, go to confluentmedical.com or, interestingly enough, nitinol.com.
Yeah, I know we're talking about anatomy, and to me that connects to teaching and education. I've spoken with several of those that you've mentored in their early career, and they've all echoed the same sentiment, which is that your mentorship goes well beyond the day-to-day training, right? And that fellowship. We've shared that, they've shared with me that you've helped them set up their practices, so much so that when someone left Paris and went to another city, you traveled with them and met with the dean to help make sure that they were set up. Even though you spent all this time training and building up that expert, quite frankly, that's amazing to me. Can you talk about the importance of mentorship to you and how you approach it?
Mentorship came with the perception, which is a growing perception, that probably what you know is more or less exceptional, and there is no reason to keep it for you. You know, you cannot just claim, I am the best in the world, first, because sometimes it's difficult to prove the contrary, and it's difficult you to prove that you are the best. But if you spread the message, if you teach as much as you can the younger generation, then you can clearly see that the fruit of all what has been settled in the past, you know, is there. You know, when you use all what you have learned and you develop and you progress and you get better and better, you know, it means that somewhere or somehow you had the proper training and you had the proper basis. So honestly, when you have this impression that it's good to deliver the message because it will help your colleague and the patient to get better and for your colleague to do better treatment, you know, you are proud of it. Really, you are proud. And probably the most beautiful things for me, the one that I am the most proud of is, you know, my pupils. Because, you know, when you come and you go and visit them, you know, 5, 10 years after, and you see what they have done, and you see how they develop, and you see how creative they are. Because, you know, creativity is also something that you have to stimulate a little bit. And it's just so rewarding. It's so rewarding. I love that.
It's wonderful.
This is the best part. This is the best part of my career, to see my pupil growing, developing, and doing things that I was not even thinking about. This is the beauty. Everybody is bringing a brick to the construction of the building. Wonderful. Wonderful.
And I know that your mentorship has evolved over the years. And to that end, some of the mentees have shared with us that your mentorship can be very personal, and that you've encouraged your fellows, of course, to dedicate themselves to their field, but also to balance time with families and loved ones. Can you expand on that a bit?
This is probably part of my professional life that was not so good. I can say, frankly, I sacrificed my family more or less, because I was so much involved in the development of this field, so much excited. So I recognize that I have been sacrificing a little bit my personal life. Nevertheless, suppose my career was not so brilliant or good or whatever, maybe I would have been a crazy guy at home. So I was not too much present, but I was not a crazy guy. I was a happy guy. So I personally, I am not the example, the kind of a guy who can say, do what I have done. Do it yourself, manage your family and your private life the way you want. But if you want to develop your professional life wherever you go and whatever the job you do, more or less you have to sacrifice the family. And to sacrifice the family, it's better if you have a support in your family, which was also the case in my environment.
Yeah. Understood. And I think that's not uncommon, right? This is a very demanding field.
Yeah.
And you're focused on patients, right? And for you, you saw the patients on what might be the worst day of their lives with their families, or amongst the worst days of their lives. And these same mentees that we talked to commented on the extraordinary level of humanity and calmness that you show the patients in advance of those procedures, which, as we talked earlier, could be high stress or high risk. What's going on in your mind at that time when you're talking to the families and you're reassuring them on your focus on their family member, knowing that the outcomes might not be great?
Well, probably one of the best part of our job is when you speak with the family, but also the day before the procedure, you go to the ward where the patient has been hospitalized the day before to pre-medicate and prepare the patient for the treatment. And then I was used to visit the patient in the ward with all the team. And my preferred moment was to sit on the bed, to take the hand of the patient, to exchange by contact and to speak frankly with the patient, with face to face, eye to eyes, trying to making him or her feeling comfortable and relax. Everything will be okay. You need this kind of, warm word before a procedure like that. And I love to do that. I share this moment with the patient. I was happy to have, the team with me sharing this moment too. And I really think that the patient goes for a short night or maybe a little bit a stress night, but much less stress compared to just saying, to the patient, see you tomorrow. No, spend time, discuss, speak with the family, present all the team because all the team is involved in the procedure. This is a very rewarding moment and strongly emotional moment. I love that. We are human and we should keep human. That's extremely important.
Someone said to me recently that Jacques Moret works for the field, not for himself. We all know that you've been involved in developing dozens of devices. You even referenced a few at the early part of this podcast. And you've given those ideas and thoughts and perspectives to companies, universities, so that other people can use them. You taught your technique to anyone that was willing to learn and to listen. And of course, we know that this saved countless lives. Something that is emerging about who you are is that you're open to sharing all of these innovations, and that things are bigger than you yourself, right? Just exclusively. Do you agree with this assessment of who you are? And did you make a conscious decision to work this way, or is this something that just evolved over time?
I agree with the concept. I agree with what you say. But I didn't think that I was thinking about it. It's my way of doing. I work freely with my sense of humanity and my heart. I didn't work for myself, or I didn't work only for myself. Honestly, I didn't work only for myself. And definitely, opening all my ideas, and my experience with the industry and with my colleague and everything, I did it with a lot of generosity.
You've seen a lot in your career, in your travels, different cultures, different technologies around the globe. Has anything surprised you about our field, neurovascular, and how it's developed?
Not really, because it's, you accept the GDC coil and the tremendous invention of Guido Guglielmi. Most of things happen progressively. It's a modification, an improvement of a given technique, and it's very rare to have something that comes like a breakthrough, boom.
Mm-hmm. Mm-hmm.
So I would say the GDC, I was really impressed. The flow diverter, I was really impressed because the stents were existing already for a long time, but the flow diverter was a brilliant idea. Endosaccular device was a brilliant idea. But today, for the last, let's say, be smart, for the last 10 years, nothing happens really. No breakthrough.
Yeah.
All what we see progressively and all about the people speak, it's basically a little bit more salt, a little bit more pepper, and that's it. From the same recipe at the origin, everybody, including me, are speaking about more salt, more speed, more spice, more oil, more vinegar. That's it. So it's a cuisine.
Yeah. So is there a burning question that remains that the next generation of innovators should really start to focus on?
Absolutely. I strongly believe that it's stupid today to keep on working without having in real time the perception of the function. You play with an organ which is, a control tower, extremely complex, and you don't know what's happening and the disaster you produce in the control tower when you work. And we have the tools to at least understand a little bit of what's happening, which is MR. For me, it's completely crazy to not develop a line of devices that are MR compatible so you can treat and have the function in real time. So I strongly believe that the real future is having the function at the time of the treatment, which is forgetting about his X-ray and doing all our procedure on MR. It will take time, not because of the MR, but because of the devices that have to be, compatible with MR, but they also have to give the same mechanical property compared to what we have with the X-ray.
So, of course, in addition to hard work and putting patients first, balancing as appropriate, as you mentioned before, do you have any advice for physicians that are entering the industry today that you'd like to share?
Well, some doctors have decided before the end of their career to switch to industry, which is fine for me. There is no question, it's fine. Honestly, working with the industry, it's a parameter that needs a new environment. We need to be able to work without any fear, freedom with the industry as far as everything is clearly exposed. And everybody knows. How can we develop things without you, and how can you develop things without us? I think we need to organize a kind of training, partner training, how to behave between industry and doctors, how to behave ethically, which is extremely important. I am not in agreement with people saying that because you receive money, you are not ethical. You can receive money to develop, but when things go wrong, you can say stop. Mm-hmm. If you continue to develop things that do not work or harm the patient because you get money, shame on you. But fortunately, it's not always the case. We have extremely fruitful cooperation between industry and doctors, and I think it has to be stimulated. This is something that I would love to see before my death, to have a clear statute to connect with industry, open, clear. So I am for a true cooperation between industry as far as you keep in the position of a doctor, which is the results are not good. I cannot continue to use this or to follow or to develop this technique or this new concept or this new material because it's not good, just because I get money. Mm-hmm. And honestly, the nature of human nature is not perfect for sure, but there are ways to control, no question about it. We need an open field. Everything has to be exposed, and as far as it's exposed, everybody knows where you go. I don't care about having somebody with strong relationship with the industry. If the device is good, if what he says is correct, and it's medically, understandable, let's go. Mm-hmm. No problem.
Before we go to the lightning round, anything else you want to say or talk about that's not part of our interview?
So I would say personally, to answer your question, we are in a wonderful environment to work, but we are not respected regarding the income. And this is a point which is definitely specific to France. According to my knowledge, there are many countries all around the world where doctors are not, really well paid. But at least here we have the freedom to do what we want. But you cannot continue this way. And this is exactly what's happening today. It's a true political message. We are missing doctors, we are missing nurses, we are dramatically missing doctors and nurses because who wants to do difficult studies, to have such a tremendous risk doing the treatment and the conflict you can get with the patient and the drama you can go through. I think it's not fair to just pay so few the medical field according to what's done in France. I'm speaking for my country because I know my country. Nevertheless, I had many offers to go to United States with wonderful salary, and I did not. And this is another song, my back parents a long time ago was Bonaparte, and Bonaparte, wanted to put France all around Europe. I am not happy with him because he didn't stop before going to Russia. Otherwise, it would have been a wonderful Europe, everybody speaking French. So because of him, I decided to not go to the United States. And but it was my decision. I feel okay with that decision. But for the future and the new generation, I don't think we can continue have this kind of politics regarding the healthcare system, because it's going to crash.
Okay, thank you. So let's go to the lightning round now, looking for one-word answers here. So whatever pops into your mind first is what we'll take. There's no right answer. If you can invite any three historical or public figures, dead or alive, to a dinner party, who would they be?
Philosophically, I'm trying to find somebody. Confucius. I would definitely invite Confucius, because I would love to get access to his wisdom. This guy, all what he wrote and all the message I got when I go to China. I have been visiting his grave in China and everything. And I think, the wisdom of this guy is just wonderful, and I would definitely invite him.
Mm-hmm.
The second one, Napoleon.
Mm-hmm.
Just to have him in front of me and telling him what a stupid guy to go to Russia. It's cold, it's unbelievable. It's another empire which is different completely. The environment is so difficult. It was absolutely crazy. And if I know well, one of his member of the family, who was the king of Rome in Italy, pushed him to go to Russia. So it was a catastrophe. So just to have the pleasure to tell him how stupid you were, in addition to that, you killed so many people. So finally, it was not good. And the third, speaking about Russia, for example, Gorbachev. I would love to invite him to discuss with him, the way he has changed the freedom in Russia and in USSR at that time. I think he gave a lot of hope for 15 years, almost 20 years, to the Russian people. Seeing what's happened today, it's a failure, but he's not responsible. At least he tried to open the door. Sure. That would be nice to have Confucius, Napoleon, and Gorbachev at the same table.
I would join.
Yeah.
If you had one book to read for the rest of your life, is there one?
I would say The Dawn of Everything.
Okay.
This is a way to look at the world. And, I just got through this book recently, and it's changing my way of thinking, definitely. The Dawn of Everything.
Are you more creative in the morning or the afternoon?
Definitely in the morning, no question. Definitely, unless I am on stress and I am a little bit late, I work at night, but basically I prefer to wake up in the morning, definitely.
And what's one talent you wish you had that you do not?
Music.
Mm-hmm.
When I was 11 years old, I was playing piano. My parents decided to push me to play piano. And when you have a father who is baker, who doesn't understand the world of music, and who is pushing you to do piano, maybe because he was living just in front of the music conservatory in Paris. So I was going there. I recorded a disc with my sister, 4 hands. And then when I got to high school, I stopped everything. And this is really a concern for me. I lost a growing or, just a growing talent. I was not so bad, but I decided to stop just to do my study, which was stupid. I could have done both at the same time. So, well, I would have, for example, I have a young son. I'm not going to push him to be a doctor, to be an engineer. If he wants to do, he will definitely to be a musician. And if he's happy with being a musician, I would love that. Definitely.
That's wonderful. I think I know the answer to this one, but do you prefer European football or American football?
None of them.
Okay.
I don't care about American football and European football. Some matches are nice to look at it, but I'm not a fan of it. I prefer to look at tennis game. Tennis
Wonderful.
game is more interesting for me.
So your favorite tennis player?
I don't know really. All those famous guys. I have no real choice. Honestly, I have no real choice. I cannot say that I prefer. The leader of the today. What's the name? Djokovic.
Mm-hmm.
I prefer Djokovic to. I am tired. The wonderful
Nadal?
tennis player. Sorry.
Nadal?
Nadal. Yeah.
Yeah.
How do you choose between Federer, Nadal, and Djokovic? No,
Exactly.
I mean,
exactly.
the personality of the guy is exceptional, but all three of them are incredible guys. So
amazing.
I don't prefer one. I prefer the personality of Federer, definitely, and Nadal compared to Djokovic. But as a player, Djokovic is just wonderful.
Yeah.
Just wonderful.
And Professor Moret, if you had not gone into medicine in those early days, what do you think you would be doing today?
I really wanted to be a doctor. My family, my parents wanted me to do an engineer study. So after the baccalaureate, I went to the preparation of polytechnics and everything. But after 1 year, it was not my field. So I decided to go to medicine. So if I did not succeed to be a doctor, maybe I would be a baker too.
Mm-hmm.
Think about the evolution of bakery today. It's so innovative. So, it's incredible to do what's done today. The taste is different. The texture is different. I am astonished by the creativity in this field. In pastry, you cannot imagine. You can imagine, but me, what I have seen in pastry and what I see today, it's true revolution. So I would have loved to participate to this evolution. So unfortunately, I was a doctor. I would have been a baker.
There are some parallels in the creativity and the innovation. I think that's fascinating. Maybe next time we do a podcast, we'll dive into the parallels between baking and interventional neuroradiology.
Yeah.
I'm gonna say thank you for the interview. This has been amazing and fascinating for me. We appreciate your time today.
Well, that is a wrap. Thanks so much for joining us on this episode of the Neuro Innovation Talks podcast. Thanks, of course, to our friends at Johnson & Johnson MedTech Neurovascular. It's been great to work with them, in particular with John Murray, who's spearheaded this effort and really helped us tell some important neurovascular stories. If you don't want to miss a future episode of Neuro Innovation Talks or our other great DeviceTalks podcasts, make sure you subscribe to the DeviceTalks podcast network. We'll have future podcast episodes sent directly to you. You can also follow us on YouTube. We'll have our audio and video portions or versions up there. So lots of great ways to keep informed and to gain great MedTech insights. Finally, make sure you share this podcast episode on LinkedIn and other social media channels. And when you do, connect with me, Tom Salemi, Editorial Director at DeviceTalks, and our great Managing Editor, Kayleen Brown. We'd love to be part of your future MedTech conversations. That's it, folks. Thanks again for joining us on this episode of the Neuro Innovation Talks podcast.